There is a telescope a million miles from Earth, and what it keeps finding should not be there. It was built to confirm what we already knew about the universe, and instead, it has been quietly dismantling it. $10 billion, 3 decades of work, and a mirror the size of a tennis court pointed at the oldest light in existence. On July 12, 2022, the first image came back, and in a patch of sky the size of a grain of sand held at arm length, thousands of galaxies stared back. The scientists who had spent careers preparing for this moment went quiet, because what they saw did not match what their models had promised. Those galaxies were not young and struggling, they were enormous and structured, and they had no right to exist that early. According to everything we knew, there had not been enough time to build something that large, that complete, that fast. Think of it this way. Imagine a time lapse of a skyscraper being built, and in the first 30 seconds of that video, the 50th floor is already complete. The lobby has a marble floor. People are eating lunch inside. You would not call the building impossible. You would say something is wrong with the tape. That is what this telescope handed scientists in the summer of 2022, a tape that does not match the construction schedule of the universe. The research papers started arriving, cautious at first, then bolder. Phrases appeared that cosmologists almost never write. Requires fundamental revision of galaxy formation theory. That is not a routine conclusion. That is a field recognizing it may have gotten something very large very wrong. The instruments were checked. The numbers were run again and again. They kept coming back the same. Something in our picture of the universe is wrong. The question is how wrong, and the answer is still being written in real time. But the impossible galaxies were only the beginning. What came next was stranger. Before this telescope, scientists had a story, built over decades, and for a long time, it matched almost everything. 13.8 billion years ago, the universe began in a single point, and within the first second, space expanded faster than light. For 380,000 years, the universe was a glowing fog too dense for light to escape. Then it cooled, the fog cleared. That light, faint and stretched by billions of years of travel, is something we can still detect today. Scientists call it the cosmic microwave background. Then gravity took over. Hydrogen clouds pulled together, denser and denser. And roughly 200 million years after the Big Bang, the first stars switched on. Those first stars gathered into primitive galaxies. Those galaxies merged and grew over billions of years into the massive spirals and ellipticals we see around us today. The key word in that entire timeline is slowly. Galaxy formation was supposed to be a slow, grinding, generational process. Nothing could shortcut it. This telescope was supposed to be the ultimate test of that model. By looking at the universe when it was only a few 100 million years old, it would confirm what we expected to find. Dim proto-galaxies, chaotic clouds of gas, the messy raw material of what would eventually become the universe we live in. That was the prediction. The telescope looked back and found the finished product already there. Massive galaxies, already formed, already dying. This is not a theory. The light from these objects is real. The distance has been measured multiple times using different techniques. What is unknown is why they exist. Scientists face a choice. Either the galaxy formation model is wrong, or our understanding of the early universe itself is wrong. Both options have been on the table since 2022, and then one specific galaxy forced the conversation from theoretical to urgent. This galaxy is dead. It has stopped forming new stars entirely. The gas that fuels star birth has been used up or expelled. It formed the vast majority of its stars within a window of roughly 800 million years, and it did all of that within the first 1.8 billion years after the Big Bang. Think about what that means. Imagine a person who was born, grew up, had children, built a career, retired, and died of old age, all before their neighbors had finished building their first house. What makes this alarming is that the telescope has now found multiple galaxies in similar situations. Massive, already finished. One theory involves black holes. When they feed, the energy released pushes gas out of the galaxy, cutting off fuel for new stars. Another possibility is that dark matter halos formed faster than we think, and if the scaffolding arrived earlier, the galaxies inside could have too. There is a clock that governs everything in the universe. It does not tick, it expands. And when astronomers say the universe is 13.8 billion years old, they are not guessing. They arrive at that number through several independent methods, each one checking the others. And these lines of evidence converge on the same answer with remarkable precision. Galaxy formation follows rules. Gravity is strong but not instant. Gas clouds collapse slowly. Stars take time to ignite. None of this can be rushed. In 2023, a team analyzed 6 galaxies from the first 700 million years after the Big Bang. All 6 were more massive than models allowed. One of them was so far outside expected parameters that the lead researcher told the press it was causing sleepless nights. That is not the language of routine science. Webb keeps finding 10 times more stellar mass in the early universe than simulations predict. 10 times. That is not a calibration error. Some argue the gap will shrink as techniques improve. Others say it signals a genuine failure in the model. Both camps are serious scientists. In 1929, an astronomer made one of the most important discoveries in the history of science. He found that galaxies are moving away from us, all of them, in every direction. Space itself is stretching, carrying galaxies along with it, the way dots on a balloon move apart as it inflates. 2 methods exist to measure cosmic expansion. For decades, they gave different answers. Both have been checked exhaustively. They still disagree. The second method uses exploding stars as distance markers. By measuring how far away they are, researchers calculate the expansion rate directly. The gap is called the Hubble tension, and it is real. Both measurements disagree by 9%. In fundamental physics, 9% is a crisis. This telescope was hoped to help resolve this tension. It provided sharper measurements of those distance-marking stars. The result published in 2024 was not comforting. The tension did not go away. Better precision made it harder to blame on error. The universe appears to expand at 2 different speeds simultaneously. You cannot see dark matter. No telescope has captured its light because it emits none. Yet we are almost certain it exists. The evidence is gravity. Galaxies rotate too fast for visible matter alone. Something unseen adds enough gravity to keep their outer stars moving together instead of drifting apart. Dark matter forms invisible halos. These massive structures pull in gas, helping it cool and gather until stars ignite and galaxies take shape. Webb finds massive early galaxies where dark matter halos should not yet exist. The cosmic scaffolding needed to build them should still be missing. It is like finding a skyscraper built overnight. Without time for its foundation, the structure should not exist when the ground was cleared yesterday. A faint glow fills the sky. Traveling for 13.8 billion years, its temperature patterns preserve a record of the universe in its earliest moments. The early universe was dense plasma, trapping light. As it cooled, atoms formed, and that ancient light finally escaped as the cosmic microwave background. Researchers found strange patterns in this ancient light. A cold spot and unusual alignments suggest a universe with structure where randomness was expected. Overlaying galaxy maps with ancient anomalies reveals a strange match. It could mean nothing or hint at cosmology's most important coincidence. Zoom out far enough and the universe stops looking like galaxies. It looks like a web-thin filament stretching millions of light years, with enormous voids between them. Webb found galaxy concentrations in the early universe far more developed than expected. Protoclusters with more structure than our best simulations ever predicted. The model tells you after 10 years you should have small villages, after 50 years, small towns. Webb is looking at a 10-year-old universe and finding the metropolitan area already roughed in. In 1998, astronomers discovered the universe isn't slowing down, it's accelerating. Something is pushing space apart. They named it dark energy. Quantum mechanics predicts dark energy 120 orders of magnitude larger than what we actually observe, the largest discrepancy in the history of science. Webb is now observing distant exploding stars with unprecedented precision, testing whether dark energy is truly constant or has changed over time. Early results produce a hint. Only a hint. But the data appears to favor a scenario where dark energy is not perfectly constant. And then Webb found something that stopped researchers cold. Fully formed spiral galaxies existing at a time when the universe was barely a fifth of its current age. The model says a river takes decades to form. Webb found it fully carved 1 week after the snow began melting. At the center of nearly every large galaxy sits a supermassive black hole. Our own Milky Way has one. In 2023, Webb detected a supermassive black hole when the universe was just 400 million years old, and already holding the mass of several million stars. Growing a supermassive black hole that fast requires a large seed feeding at maximum rate continuously. The odds of that happening even once are low. Webb keeps finding objects suggesting it happened repeatedly, not once, not twice, a pattern. And patterns in science are not coincidences, they are clues. For roughly 200 million years after the Big Bang, the universe was dark. No stars, no galaxies, no light of any kind. The first stars were enormous, hundreds of times more massive than anything today. Each lived only a few million years before dying catastrophically. In dying, they seeded the universe with something it never had before: carbon, oxygen, iron. Everything heavier than helium was forged inside these first stars. Webb found early galaxies rich in heavy elements that should have taken far longer to produce. The enrichment happened faster than our models predict. Multiple leading cosmologists have publicly stated that the Standard Model is under serious pressure. This is confirmed. This is not fringe thinking. This is the mainstream of the field speaking. One researcher described it as vertigo, like standing on ground you trusted completely and feeling it move beneath you. At least 4 serious theoretical frameworks are now being developed to explain what Webb is finding. None confirmed, all actively researched. In the Orion Nebula, Webb found planet-sized objects drifting without parent stars, suggesting planets can form independently in stellar nurseries. When a planet passes its star, light filters through its atmosphere. Webb can detect what that atmosphere contains. What it's finding is extraordinary. Webb has confirmed carbon dioxide and water vapor in exoplanet atmospheres. No biosignatures yet, but the searches are active and the data quality is sufficient. The extremely large telescope in Chile will directly image rocky planets with sensitivity far beyond Webb. It begins operation in the late 2020s. Ordinary matter, of everything made of atoms, everything visible and measurable, MAVE, makes up roughly 5% of the universe. 95% of everything is something we cannot see, detect, or explain. And now Webb is telling us the 5% we thought we understood is more complicated than we assumed. Subscribe to Noxar Flux so you never miss a story. New space documentaries are coming every single week, only on this channel.